there are likely more planets in our galaxy than there are stars. So if you take that for every galaxy, for the hundreds of billions of galaxies and the hundreds of billions of stars in our galaxy, how many planets there are. And we know also, and there's some gorgeous images coming out of James Webb and Hubble before that, of interstellar dust clouds. And in recent years, we've discovered all the prebiotic harbingers, the building blocks of biological life in those interstellar dust clouds. You know, the forerunners of DNA and RNA and sugars and proteins, amino acids,
So
lipids.
those clouds is what's going to create a planet. We need those before planets. It's always
We
clear.
need those before planets. Their environment isn't sufficiently able to nurture further complexity, but it's all there ready, including water, vast amounts of water. And a lot of that water was delivered from those interstellar dust clouds from which our planetary system collapsed when a nearby star went supernova, and the shock waves shocked, you know, a part of the interstellar dust cloud into our planetary system. So think of that happening all across the universe.
So you mean
Think of
those
that.
clouds? Sorry, those clouds carry water. You have water carried little molecules.
They have vast amounts of ice,
I
but the ice, tiny little islets are not crystalline, because if they were crystalline, they would have destroyed the prebiotic molecules. Instead, they act as little sponges and little sticky points for all the prebiotic building blocks to adhere to. So it's perfect. They're held in very coherent magnetic fields. They're bathed by the right amount of ultraviolet light to optimize them becoming to the edge of biological life, to enable that next level of planetary complexity